Hi friends, in this video I'm going to prove that work energy is equals to change in kinetic energy using calculus method. So right now, according to calculus, we know that work done is equals to integral of from initial position to final position of f with respect to position. This is the definition for work done according to calculus. But in this case, according to Newton law of motion, says that force equals to what? Mass times acceleration. In this case, our force is what? Is a vector quantity, and also what? Acceleration is also a what? Vector quantity. Then after that, since our force is equals to mass times acceleration, and this is the definition for work done according to calculus. But in this case, we can actually rewrite this as total work done, that is net work done of a body. Let me put it there, is equals to integral from initial position to final position of net force. Can you see it now? Of net force with respect to what? With respect to position. Actually, we are given that F equals to what? MA, that is my force is equals to mass times acceleration. I can actually replace this with what? With this. Then I'll be having integral from that will be initial position to what? To final position. Okay, let me put my next work done here. Okay, I will replace my this with what? With this. That will be mass times what? Times acceleration with respect to what? To position. Then what do I have to do here? I can simply bring out the mass outside, because mass is a scalar quantity. Then here we have a net work done equals to integral from what? Initial position to final position. I'm having my mass here. I'm having my what? Acceleration with respect to what? Position. But in this case, still I cannot integrate my acceleration with respect to position. I need to recall the formula for acceleration. I know that acceleration equals to what? Equals to change in velocity over what? Change in time. But in this case, we are actually using what? We are using calculus. So we'll be using instantaneous acceleration. So in this case, my acceleration will simply be the v over what? Over dt, since we are using what? Calculus. So I'm going to replace this with this. So I'm having what? Net work done equals to integral from what? From final position to what? To initial position, right? So in this case, my acceleration is what? That will be dv over what? Over dt with respect to what? To dx. Can you see? It's very simple. But okay, what other thing can I do here? Can I integrate? No, I cannot integrate, because this is velocity, and I also know that my velocity is equals to something. I can actually bring it back that velocity equals to what? Equals to change in what? Change in distance with respect to what? With respect to change in time, right? But actually, can I do it like this? If I do it like this, it's actually good. It's actually good. But I can actually say that this, I can bring this and say, okay, let's ban this one for now. We're going to use it. Here I can say, okay, in this case, my what? My dv dt, in this case, I can say, okay, because since my v equals to what? Velocity equals to distance over what? Over time, right? I can actually say that my dv dt equals to what? Equals to dv over dx multiplied by what? Multiplied by dx over what? Over dt. Yes, according to product rule, I can actually use this, because this will cancel this. Once this cancel out this, I'm having what? My dv dt back. That's chain rule actually. Thank you. I'm having what? Dv dt back. Can you see that? It's very simple. But in this case, what do you think I can do here? Okay, I can actually replace this with what? With this, so that I'll be having what? Net work done equals to what? Integral from what? From final position to what? Initial position, right? I'm having, instead of writing dv dt, I'll be writing what? Dv over what? Over dx multiplied by what? Dx over what? Over dt, right? With respect to what? My dx. But in this case, this will cancel out this, right? So I'll be having net work done equals to my mass is there actually, sorry, my mass is outside. So I'll be having my mass integral from what initial position to what final position of what that's I'll be having the x over dt. Then I'll bring this dv out. That will be traces what dv. Right? But do you know one thing? You know, from this I said velocity equals what changing distance, position divided by what changing what in time. But if you look at this, the x over dt is also according to instantaneous velocity. This is the formula for what instantaneous velocity. Instantaneous velocity is given by v equals to what the x over dt. Can you see it? But in this case, I can actually replace my v with what with this. Very good. It's very superb. I'm having what next work done equals to what my mass integral from what initial position to what to final position of what of velocity with respect to what dv. Yeah, here can I differentiate? Actually, I can differentiate, but you can see that this is having limits, upper limit and so lower limit. But I don't need to rush things since I've changed my variable here. I need to change this and also this. This in this case, I'm going to replace both of them with what with velocity. So I'm having what next work done equals to what my mass multiplied by integral of final velocity to what initial velocity of what velocity with respect to what dv. Then here I can integrate successfully. And if I'm integrating this actually you already have little knowledge about integration, so I will be integrating directly here. So I'm having what net work done equals to what equals to mass into bracket what. If you integrate this, you're having what v raised to the power of 2 divided by what 2. Then from what from final velocity to what initial what velocity. Can you see that? So now in this case, actually is very good. So what is it I can do here? I can just separate them because I'm having upper limit and also lower limit here. I'll be having next work done is equals to mass. Let me just put it in the calculator, or let me just use this one. That's really good. Mass multiplied by that will be v square. I'll be replacing this with this my v into bracket. Let me put inside bracket. That will be v square over 2. That's my final v, right? Minus that's v square over 2, which is my initial v, right? So okay, I can actually open the bracket directly here. Show that my next work done will be equals to what mass multiply what final velocity over 2 minus what mass multiply what initial velocity square over 2. But actually, you don't want to in physics, I can actually use my initial velocity. I can donate it with u. I can say let's what vi equals what u, right? Show that I'll be having what next work done equals what mass times what v square, my final velocity over 2 minus what mass times what u square, which is my initial velocity over 2. Can you see that? But actually, in this case, there is one thing I can actually do here. I can recall that's what the formula for kinetic energy, kinetic energy equals to what half of mass multiplied by my velocity square, right? So now if kinetic energy is equals to this, then my change in kinetic energy, that will be what half of mass, half of my initial kinetic energy, which is this, my final minus what 1 over 2, let me use mu square, which is my initial kinetic energy. So in this case now, I can record this. I'm having what next work done equals to what mv square from, look at, so this is what final over 2. I'm not putting it now. Minus what mu square over 2. Then okay, what else can I do in order to make this to be equals to this? I can actually factorize 1 over 2 out, which is net work done equals to what 1 over 2 mv square, which is what our final kinetic energy, minus what 1 over 2 mu square, which is what my initial kinetic energy. Can you see now that we actually prove that net work done is equals to what 1 over 2 mv square minus 1 over 2 what mu square, which is net work done equals to what change in kinetic energy. So now in this case, what's actually happening is that the total work done the total work done by what? By a particular object is equals to the what? Change in kinetic energy of what? Of the object. Can you see it now? So in this case, this is actually what? This is actually proved. Although kinetic energy is a theory, but it is actually something that is what? That is true. So this is the right what? Right answer. Right formula. So now we have proved that work done equals to a change in kinetic energy using calculus method. So if you haven't subscribed to my YouTube channel, kindly hit the button and click on the what? Click on the bell for it to be what? You actually receive a notification so that you know whenever I drop another video. So thanks for watching.